Hello and welcome everyone at guix.social. Today we talk about array and arrays, a modern and extensible IDE for Guile scheme. The talk will consist of 4 parts. The first one will be a bit of motivation and demo of basic functionality. The second one will be a dive into internals of array and arrays, how it works and why it's designed this way. The third part will be a practice of setting up an environment for Guile project using Guix. And the last part will be the live coding or demo of using Guix API and showing how to develop a real Guix related project with array. Being it your personal configuration, a channel, or even a bigger project. I'm Andrew Trocken. I work on operating systems and programming languages. I'm the author of Guix Home, RDE, Array and Arrays, and other free and open source projects. Let's talk a bit about motivation of why this tool appeared at the first place. I came from a Clojure background and I used to highly interactive development workflow. So you can reevaluate parts of the code, restart parts of the system, restart tests without losing state of your application. So it hugely reduces the feedback loop. So you can see in like real time the state of your application, what data is flowing from one endpoint to another, and how it interacts with each other. It was possible with Cider IDE for Emacs. I think the same experience of people using Calvo for VS Code and many other people like programming in Clojure. Unfortunately, when I was hacking on the first versions of Guix Home, this experience for Scheme was not here. Partly because of Guile. Despite the fact that this language was developed as a substitution for Emacs Lisp and Emacs to bring, this Lisp machine feeling to the whole operating system, it's not yet here. And most time people use the Guile, they run it from a command line and it's not interactive. It's like rerunning every time all the scripts written not in a bash but in a Guile scheme. Partly, the interactive workflow is implemented through extension to Emacs called Geyser, and it allows to interact with Guile REPL, and it gives you a bit of interactivity, but it's not a complete interactivity because of many important things. The problems with continuation, no STD handling, interruption of long-running processes, nested REPLs which messes up all other functionality of IDE, no live STD out, and other like really important and basic things that should be here but not yet here. If you want to see those cases and how they fails, you can see my talk on EmacsConf 2023 and the talk called Bringing the Joy to Scheme Programming. The obvious question, why not just to fix Geyser? I tried, I implemented a test runner for Surface 64, I tried to fix some things of the Geyser, but unfortunately it's not that extension friendly, and it took too much time to fight with the Geyser internals instead of like actually getting some results. And that is why at this moment I just gave up and was like restarting every time my application, even doing a very small changes to see the results. I was inserting some debug output and restarting the whole application, which could take from seconds to minutes to like really evaluate and complete the execution. While in Clojure land, I would spend like a couple of fractions of seconds to reevaluate part of the code I am interested in and test on the already existing data or state of my application. But after a few months living such a life, I felt a bit of frustration, and I felt a bit miserable programming and Lisp and not having this, Lisp machine feeling. And this is why we started to develop Array ID. But before talking about internals, how it's designed and how it works, we will see a basic demo of base functionality that you will use in any scheme project you will be working on. On the right, you can see we have an REPL server started on port blah blah blah. We can connect to it through Ctrl+C, Ctrl+A, and it automatically discovers the required port and connects to it due to an REPL socket file in the root of the project directory. We will start from very simple expressions that we will be evaluating and see the results. First one will be just displaying a string to stdout. We evaluate display. We see that a result of this expression is unspecified and the output is just high. You can see the difference between phases for stdout and for the value of the expression. If we do the same but provide the output to stdr or current error port, you will see that the phase for errors is a bit different. The expression is the same phase. Of course, we can evaluate expressions which returns a few values. And here you can see the result, and it's visible on the right, two expressions, and on the left you see those boxes showing the result in line in the buffer using overlay capabilities of Emacs. Of course, we can see in which model we are currently, and you can see that the evaluation happens in the context of the current model, which is defined at the top of the file. Okay, going further, we know that there is a function called call with escape continuation, and if we try to type part of the function name, you will see the completions. But if we try to type ask, we don't see the completion. This is because the model containing this function is not yet imported. And for our completion to work in this case, we need first import this model. I imported it here, and you can see the return value is unspecified. And now, if I try to type the same thing, it will show the completion candidate. And you can see that when we have this thing completed, at the bottom of the screen you see eldoc hint, which says that the call with escape continuation comes from ICE9 control model, and it accepts one argument a procedure. You can see more detailed documentation currently using info manual. I use Ctrl+H and capital S, and here you can see it automatically completed to call with escape continuation, and I press enter and I see the description of the function and all the documentation. There is no separate functionality for handling documentation yet in the IDE, but this one built in Emacs is already good enough. Also, I can go to definition using the basic xref functionality, because we provide a backend for xref, and you just type alt dot and jump to the definition of the function. And you can jump even further to see the implementation of internal things, and jump as far as you want. And you of course can jump back using alt alt comma, and come back to the original place where you started your navigation to the dependency tree of this function. Okay. This is all already possible with other IDE we talked earlier today. But what is not yet possible in those IDE is running a long-lasting process, probably possibly infinite loops or infinite recursions or something like this. And you can see that it prints stdout values as soon as they appears. And you can see in real time what happens with your code using some debug output. It's especially helpful when you try to debug some part of the code and you trace some values inside it, and you want to see right now what's happening with this code. And sometimes you accidentally run infinite loop or something like this, and you want to interrupt it. And it's very easy. You just type Ctrl+C, Ctrl+I, or function using IDE, and the evaluation stopped right here, and you can continue to do other things. But more importantly, even when you start your infinite process, you still have a completion call with. You see, the completion script still works. The go to definition, the go to definition still works, and all other things are here, despite the running process in your kind repo buffer. Okay, let's interrupt this infinite loop and do one more trick, which is not easier. We can access stdin from our IDE. For example, somewhere in your code you have a read line which requires some input from stdin. What will happen with geyser? It will freeze. What will happen with array when I evaluate this code? You will see the prompt of the bottom IDE saying stdin. And here I can provide some value. Hello, I'm a value from mini buffer. And you can see that read line returns a string that we typed right now. The next feature that we have a proper continuation handling. The reason why we can do a proper continuation handling is because we have one evaluation thread, and we asynchronously can send different commands to it to either interrupt and start evaluating a different code or do some other fancy stuff. And when we save some continuation, we save it in the context of this evaluation thread, and we can resume this evaluation in this evaluation thread. Let's do a bit more involved infinite loop. Let's first define a variable cont where we will be storing our continuation, and let's start another infinite loop. And you can see it prints some numbers, and I want to interrupt the evaluation. I interrupted it, but if you take a look at the internals of our loop, you will see that every time, every tick of the loop, we save the value of continuation to cont variable. So in our cont variable, if we take a look at it right now, we will see the saved continuation inside it. And I can call this continuation by providing a value to it. And important part here, you saw that we stopped our loop after index 45, and it had default suffix. And we call the continuation with a different suffix, which is hehe. And after calling the continuation, it continued the loop from the place we stopped before, but with a different suffix right now. And of course we can use again a different suffix, and you can see we continued the previous execution. We can even try to evaluate both of them and interrupt both of them. And when I start the evaluation, you can see here at the top of the IDE that evaluation in progress and how many requests right now in the queue. And you see when the first evaluation stops, the next evaluation starts. Let's see one more interesting example is a combination of continuation example and a readline example. We call our continuation with a different value, which is read number. And here inside the loop, if our suffix is equal to read number, it will ask a number from stdin and update the suffix and update the index we are right now. So let's call it. You see at the bottom of the screen stdin prompt. We input some number. We type enter. And you can see after the read number, our loop continued with a different index value and with a different suffix. Having such interactive environment is really simplifies your life, and it really helped me to understand how continuations, how delimited continuations works, because I could really do all those examples interactively and play with them. I could do the same, restarting every time the process from the beginning, from CLI, but it won't be that, educationally useful. It would be useful, but not that fun. Okay, let's jump into a bit more technical details. The IDE consists of two parts, array and arrays. Arrays is written in Guile scheme and array written in Emacs Lisp. Why we have two things? First one, who can be more knowledgeable about Guile process than the Guile process itself? The second one, we have a separate front-end part, so we can integrate with many different front-ends, for example, Emacs, Vim, VS Code, or whatever else, CLI, everything will be talking the same way with the one backend implementation. And the backend implementation will be providing all the heavy lifting, the after completion, the evaluation, the refactoring, macros expansion, and all the fancy stuff. The backend part requires to be executed in some specific environment. The environment of the Guile process usually defined by load pass. Basically, load pass is the place or a collection of places where Guile look for the source code. It can be set by environment variable, by -l flag. It can be hard-coded build time during the build of the Guile, or can be added interactively with a function like add to load pass or something similar. I have a few snippets of code that you can use to explore how load pass looks for your Guile process, and I have a separate talk called Guile load pass explained, where I dive into a bit more details about this important concept. But what we need to just start our arrays process inside prepared Guile environment. That's it. And later today we will see how to do it with a guix and guix shell. The second thing, front-end part of course have to communicate with the backend part somehow. For this, usually a protocol needed. And luckily enough, we have such protocol. It's called Enable. It was developed for Cider environment, for Clojure. It's asynchronous, it's extension friendly. It uses Bencode, the same encoding used for BitTorrents, but it can use other transports like JSON, EDN, whatever else you can come up with. But by default, it's a Bencode, and right now we implemented only Bencode support. The in almost any language, in I don't know 50 or 100 lines of code, it's like really simple. And the protocol itself is also quite simple. It have a notion of session, and it have a notion of messages. Each message should have session and ID of the message. First and only first message and only one operation that don't have to have a session is operation clone. You send this operation, you get the response from the server that new session is created. And now you send all other requests and use all other operations in context of some session. It's either this session or new session created by another OP clone call. And here you can see a simple example of evaluation using this protocol. We send operation eval code, the string containing the code, and session, already existing session here, and the ID of the request. We get the response that our code printed a hi to stdout, hi \n, and also it returned an unspecified value. And now our frontend asynchronously can do operations like showing what happens with stdout, showing what value returned by the whole evaluation, and marking the evaluation process as done. That's very simple, and protocol is well defined. The documentation is not 100% complete, but it's very good and covers many use cases. Why not using some other more popular, more older, or whatever protocol? There are like a few alternatives that I was looking at. It's Slime, LSP, and probably few more. The Slime is just didn't feel right. It missed some functionality and was not that well defined and not covered all the use cases that we actually needed for our IDE. So I decided why to bother with Slime and trying to implement it, while we have a bit more extensive coverage in nREPL protocol. They are kind of similar, but I just felt that nREPL is a bit more advanced and covers more important tools. LSP is a very good protocol, very popular, cover a lot of things, provides a lot of stuff, but it's too complicated. Like implementing something fast is will take much more time. Will just take much more time, and it uses JSON. As far as I know, it's like a primary option, and even implementing a JSON parser in the language that don't have it. For example, when you will be implementing HOOT integration, you will need to implement a JSON parser yourself. Parsing and serialization, of course, and all that stuff. Beancode is a bit easier on this regard. But there are like a few more protocols, including Jupyter Notebook, and theoretically we can use all of them. We are not restricted with nREPL, but the nREPL is currently the primary one, which is implemented right now. Maybe later we will switch to LSP or Jupyter Notebook. We'll see how it goes, but for now nREPL covers all the use cases we need. Another question. Why we need to start our nREPL server separately, like in CLI or somewhere, using makefiles or whatever? The answer is quite straightforward. We don't have a new unified project or environment management tool at the moment for Guile, and there is no like standard way of running a Guile process, a standard way of setting load passes for it. So there is no standard way to store this information about the environment. This is why we explicitly require to be this process started by a person who developing this project. It's a bit less user-friendly, but it's implicit, and it makes it, in my opinion, more obvious what is happening under the hood. And talking about extensibility, if we take a look at our source code, I already recorded a demo about go-to model and other quality of life improvements, but they probably won't be in the final edit of this video. This is why you can see it here during our theoretical part. What is important here? We have a REST extensions module, and you will see that there is a whole directory of things here, which is extensions to our IDE. First list of extensions is Ares Core, which provides the basic functionality of handling requests and state management. The second one is bin code extension, which provides like serialization and deserialization of messages. The next one is extensions extension, which provide an ability to add extensions in runtime, and a few more, which are not that important. But what is important is extensions which implements in REPL functionality. So you can already see that basically our nREPL server is just constructed from a combination of composable extensions, which adds std-in and std-out support for interacting with a remote process using socket, for example, state management, extension management, bin code, serialization, deserialization, and so on. And on top of this, we implement the nREPL functionality, the session management here, the completion functionality here, evaluation functionality here, and lookup functionality here. But if you take a look, for example, at very complex topic of evaluation, you will see that there is no so much code here. This is because all evaluation related functionality is implemented in a different module called Ares evaluation. Oops. Okay. For some reason, this is because we didn't require this extension anyway. If we do use models, Ares extensions, Ares, how it was called? Core, okay? Ares, go to model, Ares Core. Extension, sorry. And there was another one called nREPL evaluation, and now we can go to it, nREPL evaluation. Okay, good. And now array still shows it is disconnected. Why it's not associated? Okay, I don't actually know. It's very strange. It should be Sesman link with buffer. Okay, now it's connected. Actually, it should be automatically associated, but I don't know why it's not. We see that it requires Ares evaluation model here. And if we evaluate this model, our go-to model Ares evaluation will be available here. And this model have much more code related to evaluation. And all the heavy lifting is happening here. And also in another model, which is reusable threads, which also do some magic stuff necessary for evaluation. Okay. Going back to our nodes, the system implemented in the way that we have many different composable extensions that can be combined with each other to build this event loop which can process asynchronous messages, and it is so extensible that you can even change the way the state, the interaction with socket, the serialization, deserialization works, and actually provides any protocol on top of these extensions. And of course, the common part which is not related to protocol is implemented in different namespaces and can be used either as a library or as a part of a different server or a different protocol implementation. for example, LSP. So it's possible that other protocol will be implemented in this project as well. Let's build an environment for running a Guile process using Guix. As we talked later, for defining an environment, we need to have appropriate load path. And to get appropriate load path, we can use a Guix shell, which will set up the load path for ours using environment variables. But you need to be careful here, because you need to have a consumer package which will set up this environment variable. In our case, consumer package will be a Guile next package. For now, we need to use Guile next with rs because it uses custom textual ports, which is not available in current Guile at the moment. And let's open a terminal. And inside this terminal, let's try a few commands. First one, your Guix shell will be using packages which are available in your current Guix profile. And current Guix profile is what the Guix describe returns to you. It located in config Guix current. It is a symlink to your current Guix profile. And depending on the channels used for your last Guix pool, the packages that are available for your Guix shell can be different. And for other person, his channels configuration also can be different. And if you use the same Guix shell command, you can get the different results because of it, because you have different current Guix. To avoid this, we will be using channels SCM file and time machine, Guix time machine, which will allow to use channels SCM to get a predefined version of Guix, and we will be using Guix shell with this channels configuration and get the exact versions of our packages in our environment. But before going to it, let's see what those commands provides us. As you can see, if we try to do Guix shell and provide Guile package here, our Guile load path won't be set at all, because we don't have a consumer package. To get the Guile load path variable set in the environment of Guix shell, we need a consumer package, which will be a Guile next, and at this example. And here you can see that Guile load path is set when we used a consumer package in our Guix shell definition. But to make our Guix shell use the same version of Guile next and Guile rs, we will need to define our channels. For this, I created a special file which is located in env Guile sgp subdirectory, and the module defined here will be sgp channels, and we will need it as a module later. For now, just remember that we define two channels here. First one for Guix and the second one for RDE, because RDE contains a bit more fresh Guile rs and Emacs array versions. We defined two channels. Now, how we can use them? To use them, we will be using Guix time machine command and specifying this file to -C CLI argument. After that, we specify -- and shell, and after that a list of packages. So basically now we are sure that our Guile next and Guile rs packages are coming from those channels, from a particular versions, from a particular commits, and they will be the same for me and for the person who will be using the same project with the same make file. Now we are sure that the versions are the same. We need to add a few more things to our environment. First one is the Guix itself, and this Guix should be built with Guile next, and more importantly, it should be of a version which defined in our channels. For this, we have another namespace or module called packages, which uses our SGP channels, and it defines a package called guix from my channels, which takes the value of the guix channel from the file we saw earlier. It inherits from original guix, but using the source code with our commit defined in our channels SCM file. And of course, it uses guile next instead of guile in the inputs. This way, we got a more up-to-date guix with latest source code and built with guile next. The second thing that we will do here, we will build a package which contains the source code of all other channels to make it available in our load path. And the definition will be simple, and it will be using guix for channels, but it's a bit custom version of guix for channels version, not the one available in guix, because it inherits from guix from my channels instead of usual guix. And this way, we will get all the source code of all the channels from our channels SCM in our load path available for us by providing those two expressions to our guix shell. And of course, for this expression to work, we need to make a shell command aware of the source code. So we need to add a -l flag specifying the directory with definition for those packages allocated. And after that, we will get the environment where we have exact versions of guile arrays, exact version of guile next obtained from those channels, and we have the source code for guix, and we have the source code for channels available in our load path. And after that, we just run our guile process with all necessary environments here. This one is not actually important, and this is a command that will be executed inside our guile process on startup. First thing we will do here, we will require guix.exp model, and after that, we will run an REPL server. We need to load this model before starting an REPL server because of the way reader macros works. This one will trigger the loading of guix macros will be stored in dynamic state that will be inherited by all which will be executed later by an REPL server. And it's really important to have the guix reader macro available for all evaluation threads and for all child processes that will be executed by an REPL server. That's basically how we get the working environment for a guile project with the source code for the channels available in load path 2. The last but not least, and probably the funniest part of the talk, is a demo of using array with a real guix API. And here is a very simple demo. We import usual models like the packages, some services, guix.exp, and a special RD API store model which contains some wrappers around guix store API, which allows to use functions like build with store and eval with store directly with the packages and G expressions. And here, the simplest example, we take a package S2E and build it with store, and it provides us, as a result, an item in GNU store which contains the binary, the documentation, and other things that are inside our package. Also, we can of course evaluate G expressions and get results back out of it, but we can also build different things, not only packages and G expressions, but also directory unions. For example, here I make a directory union which contains htop and food, and we can build it and see that inside this directory, inside bin folder, we have both food and htop semi-linked to this directory union. Moreover, we can build a program file. It's basically a scheme script out of G expression, and inside this G expression we can reference packages and binaries inside those packages. But not only packages, but also other things like directory union that we've built previously, just before this example. Let's make a very simple script that takes a food terminal, runs it, and provides htop as first argument, CLI argument to food. So our food terminal will have htop run out of the box. And let's define such program file. Let's build it. And as the result, which will be stored in run htop binary, will be a path to the store, which contains the script. And as you can see, it is the same script as G expression we wrote here. But with the path to the binaries is expanded to the respective store items. We have my CLI tools, directory union, and bin food and bin htop here. And now, of course, we can just take this run htop binary and run it from our Guile process, like this. You have a terminal and you have htop executed in it, and it works perfectly fine and very interactive. The second part of the demo will be a bit more complex. So to emulate the real-world usage scenario, you already have some home environment defined somehow in a few files which contains a lot of home services. And here I use IDE to define this home environment from a list of features. And you don't need to understand how it actually works. The only thing that you need to understand is that you already have some home environment here, which contains a lot of stuff inside, and we can build this home environment with our usual guix home command or using our IDE and build this store helper. You can see to build this home environment it takes like a bit of time, at least few seconds, and if this environment will contain much more services, it will take up to a few minutes, which can be like a really time consuming. Every time you're doing any changes to your configuration, wait until everything is built. But luckily, to get understanding of what is happening in some part of this home environment, we don't need to rebuild the whole thing. But the whole thing is good. We have like a configuration files here for everything specified in our config. We have our profile with binaries from all the packages we included somehow. We have libraries, documentations, and so on. But we don't need all of this thing if we focused on some part and improving some part of our setup. For example, we can take a look at what configuration files are inside our home environment that will be built. And right now we see like there are a lot of files will be built, which comes from DistroBox, Podman, and ZSH. Let's comment out this line and let's take a look at few helpers. First helper is getConfigs. It takes RD configuration and it extracts home environment out of it. So you can basically put like a usual home environment definition or variable containing your home environment here. And from this home environment we extracting a list of services. And after that we do a fold services. But instead of like building the whole graph, we take only the part of the graph which ends up in home file service, and we obtain a value from this part of the graph using service value function. So, and using this function, we can get this list of configurations right here and see what is inside our home environment files directory that we saw before when we built this home environment here. But again, I executed the building of the environment, and it took some time. And inside this files config, we can see all those files mentioned above. Okay, so good so far. Let's do a more focused development. We are not interested in the whole home environment, but right now we are interested only in ZSHRC configuration and its content. We want to understand what is going to our ZSHRC configuration, and we don't want to build all the configuration files, all the packages, and all that stuff. For this, we can take our configs, filter them, and find only the file names equal to this one, and see what will be the result. The result will be a list of one configuration file, and to extract the actual content of this file, we need to take this item out of the list using this cadr function and build it with store to see the actual content of the final ZSHRC. And we see this ZSHRC configuration contains some predefined default settings. After that, it contains settings related to DistroBox and settings related to Podman. Actually, we didn't update this configuration. Let's do it again. Yes, this is what is corresponds to these configurations written here. Here, between DistroBox and Podman configuration, you see also the configuration for ZSH after suggest. But if we disable this plugin, update our configuration, and rebuild our ZSHRC, you can see it takes like a fraction of a second to rebuild, and now we don't have this ZSH after suggestion configuration. Also, if we disable feature DistroBox, rebuild our ZSHRC configuration, I forgot to disable substitutes, so it does a check which is unnecessary and rebuilds almost immediately ZSHRC after that. And you will see that DistroBox configuration will also disappear from our ZSHRC config. And as you can see, we took only a small part of our system and interactively tried to change this part and see how it goes. We also can write tests and do not manual inspection of the file content, but having some automated mechanism for checking that this string is presented in our configuration file, or it has a special format, or some other constraints are satisfied. So this is the example of what you actually feel when you develop your project in a very interactive and fluent way with a very short feedback loop. Thank you for your attention. I will see you in a bit in Q&A session. I wrote down a few questions and I would like to read them first, and we'll try to answer.
Great.
Cool. I have one question about macro expander support. The macro expander. Let's see how the macro expander works. I need to connect to a REPL, and now I need to write something here. When something do something one and do another something. Okay, we have this very simple when statement. It has a condition and it has a body with two statements, and probably the first one should be like something with side effect to be useful, and it returns the last the value of the last expression here. The last expression is the following. Or we can make another nested expression plus 1, 2. And we want to understand how the when thing work. We can, of course, go to definition, and we see that it is a macro with defined syntax rule, blah, blah, blah. But having the macro definition is not very useful, especially for like big nested combination of macros, because you will need to interpret this stuff in your head, which can be like really hard. And for this thing, we actually have, I think it's Control C, yeah. You can see we have a macro expander, which will transform the original expression into expanded expression. And now you can actually understand what is going on inside. So it's basically an if statement without else statement. You can see that there's only one branch here. And this branch actually a wrapper which wraps all the forms listed in when statement into begin. And that means all the statements will be evaluated and the value of the statement will be returned. So that's basically how macro expander in array works right now. What is what my easiest way to try all this in Guix, please? Question mark. Inside root of the directory, you can see a make file. So basically what you need to run the nREPL server, you just run make res. And if you have Guix installed, everything else will be available to you. And of course, you need to install Emacs array. You can do it with a very simple command, something like guix shell emacs array minus emacs, and you will have Emacs with Emacs array available for you. Also, you can take a look at the documentation of Emacs array repository. In the README, there's instruction, if I remember correctly, but I hope you will be able to install Emacs array easily, some way at least. Will array arrays have a debugger like Slime in the future, or should we just keep using the pk macro? Pk macro is the macro which prints some stuff to std out, and probably it prints some. Does it print a place or a form? I don't remember. But anyway, it's just a debugging output. There's some work on a debugger prototype by Alexander Vitizev, and it's already he already have some integration with array, but the debugger itself is pretty bare bone and experimental. It won't like handle arbitrary Guile code, only some code with not much macros inside it, but there's already work in this direction. And I hope in the future, probably with the help of Andy and some other knowledgeable folks, we will provide like a full debugging experience, and probably it will be much more interactive than it's possible in other languages. At least I hope so. It's like a really far future, but it's definitely possible. Let's find the repository for the debugger implementation. The first one is a debugger implementation in Guile, and the second one is integration with array. The way to see a backtrace, no, you can. The function for printing exceptions, and of course, somewhere here you can add some logic for printing backtraces, but not out of the box, I guess. Another question about meta comments. There's a feature in usual scheme REPL, which called meta comments when you type comma and after that you type something, and it provides some result to you. Most of the comments, or most of the meta comments I saw was not very helpful in a sense that they just provide a usual functionalities and that you can usually access by API, but for some reason they hidden behind these meta comments. And I had like a very I was very skeptical about meta comments and didn't care about them at all. But after that, I realized that there are some useful meta comments which changes the context of the REPL. So you can type some special meta comment and you get into the context where like your Fibers scheduler available, or Goblin's VAT available, or Geeks store available, and you can like build derivations easier. Many of those use cases can be covered by a good API, and you will be able like to call those API directly. At least for the Fibers use case, I was successfully run all the necessary stuff for operating with Fibers. It's a bit more verbose because you have explicitly specified scheduler and other stuff to make it work, but it's possible. So you can live without meta comments, but they definitely improve user experience. And probably we either start supporting meta comments at some point, or we will find an alternative way to provide those contexts. We need to think about it, but something for this will appear in the future for sure. There was a question, I don't remember exact wording, but Jorge said that he wants a REPL because sometimes he just wants to put an S expression inside REPL and not not make a mess in his file for the source code. I have two answers to this question. The first one, usually for like interactive workflow, I have the working buffer, like a real source code, a part of code base, but I also have a special directory called dev, and inside this directory I have a few draft files where I can place some expressions to evaluate. Maybe they have some structure, maybe they have some models, but I do it like, Scratch buffer, but Scratch files in a separate directory that I add to load pass only during the development. And when I finish the development, the final library doesn't contain all those drafted files. This is a first approach. I solve this problem of messing up your real code base. And the second one, there's a command called array evaluate as expression, which similar to eval expression Emacs command, which shows you a prompt at the bottom of Emacs, and you can type any expression in it, and it will be evaluated. The only downside of this command at the moment that you won't see this command recorded in your output buffer. But you can already do the same things that you can do in the REPL without actually having a prompt and all that stuff. Does array have documentation? Symbol lookup in manual support, similar to Geyser. We don't have anything, almost anything related to documentation except LDocs, the thing that appears at the bottom of the screen and shows a signature of the function. And we not implemented any integration with info manuals and all the things. But I showed earlier, you already have Control H capital S hotkey, which allows to find the symbol under your cursor in the info manual and just straight navigate to the page where it defined. There's some special, as I understood from the chat later, there's some special adjustments to info lookup a list something look variables, which makes it a bit more precise, the finding the documentation, but we don't do anything to it yet. Another very good question, Guile. I don't know if it is a question or a statement, but I will read it as it was. Guile doesn't have built tool like Leningen, question mark. There are like a few build tools in Clojure world. Leningen, Depth Hidden, Boot, maybe something else that I don't remember. And they all perform a few important roles. They allow us to first manage dependencies, like list all the dependencies, and the second, construct profiles and load passes. And for now, the Guile lacking such tooling. You can do some parts of it with gigs and probably Guile Hall, if I remember correctly the project name. I remember the two similar projects which have similar names and similar purpose, but they are not quite equal to what Depth Eden provides in Clojure World. And I think that it would be cool to have a separate, not a package manager, but more environment or project management tool for Guile, which won't depend on gigs, because gigs still like a very huge dependency. I had experience in summer programming school where I was teaching people to use Lisp, and the first task was to install gigs, and our Wi-Fi couldn't handle gigs pool, and it take like half of the day just to install gigs on laptops of the students, and only half of the students succeeded. So I had to like merge pairs to continue our studies. So it would be cool to have something lightweight and independent from gigs. And I think we are finished with the questions. Anything else we can do?
Do you want to mention your streams and how people can follow along with this project?
Okay, you can follow those projects on RD Devil mailing list and on the repositories of those projects. And I also stream from time to time and make educational videos and upload them to YouTube and PeerTube. Maybe in the future I will switch to PeerTube and Owncast. Maybe I will still use YouTube, but for now, the primary source of video content from me is YouTube channel. What else I can say? I also write posts in my Mastodon account, and you can find my social networks in on my personal page. So you can reach me out by those contacts and talk to me, or maybe to other developers of our projects.
So I think all that remains is to thank Andrew. Thanks, Andrew. It was great.
Okay, thank you very much for joining to everyone. It was a pleasure to chat with you and spend time with you. Thank you.